Hi, welcome to Lesson 4 of the Introduction to Python course. In this lesson, we will be discussing Python strings with a focus on string basics, special characters, multi-line strings, indexing and slicing strings, common string operators and methods, formatting strings, and built-in string functions. Now, according to the Python documentation, strings are defined as immutable sequences of Unicode code points. The more simpler version of this is that strings are sequences of characters. In Python, the term sequence refers to an ordered set. Some common sequence types are lists, tuples, and ranges, which will all be covered within this lesson. Let's start with quotation marks and special characters. Now, strings can be created with the help of either single quotes or double quotes. There really is no exact difference between the two. However, they are used interchangeably according to convenience. Now let's take a look at escaping characters. If we want to create a string that contains just one single quote, we enclose the string in double quotes like this. Let's say we have a variable phrase, and within this variable, we will be assigning our quote. So we put double quotes and then we put our sentence, something like, where'd you get the coconuts? Now, if you want to create a string that has two quotes in it, we enclose the string in single quotes, like this. Phrase equal to, the soldier asked, are you suggesting that cocoa nuts migrate? Sometimes we need to output single quotes within a string that is denoted by single quotes, or we need to output double quotes within a string that is denoted by double quotes. In situations like this, we need to escape the quotation marks with the help of the backslash, like this. Phrase equal to, the soldier asked, are you suggesting that coconuts migrate? Now, in this case, we put the backslash here and here. Then we can print the phrase. Another way of doing this is like this. Phrase equal to, the soldier asked, in this case, we will use a single quote, and let's see how this works. So we put the backslash here, and then we continue. Now, another way of doing this is like this. So we say phrase equal to, the soldier asked, now another way of doing this is like this. So we have phrase equal to, in this case we will use a slightly different sentence, which is the soldier said, "You've got 2 halves of a coconut." Now in this case, we put the backslash here. Now we print the phrase and it comes like this. And if you've noticed, in both of these cases, the backslashes are not printed out. That's because the interpreter understands that the backslash is only for the program's understanding and it is not meant to be outputted. Now let's have a look at some special characters. So we've already seen how a backslash can be used. Now, suppose we want to use a backslash in a sentence and we don't want the interpreter to just interpret it as a character that is only meant for the program to interpret. So in such situations, we can use another backslash to escape the current backslash. I know that sounds quite complex, but let's look at an example. So let's say we have a phrase which says use an extra backslash to output a backslash. Now when we print this phrase, we get only one backslash and the other one is not printed out. So let's have a look at what would happen if we did not have this extra backslash. It would give us a syntax error because it assumes, the program assumes that we are trying to escape this particular character, and that is not the case. So when we add this extra backslash, the program understands what exactly we need to print out. Now, 2 other common and special characters are the new line and the horizontal tab. So let's say we have something like this: print equation horizontal tab solution new line 55x11 horizontal tab 605 new line 132 regular slash 6 horizontal tab 22. Now when we print this, it comes out in tabular form. So these are just some other ways of... So this is just a basic summary of what we have learned so far. Now let's come to raw strings. Now, sometimes a string might have several backslashes, but the string just needs the backslashes in them, and we're not trying to escape any characters. An example of this is when we have a file path. As you can see here, the file path is C drive, then we have a backslash, news, backslash, and then the file name. Now, if we just type this in directly, so for example, let's say my path, and we have C colon backslash news backslash today.txt, and when we print my path, as you can see, it prints out something really strange. It considers this to be a new line, and it considers this to be a horizontal tab, and it just messes up whatever we want to actually print out. So when we use R for raw data as a prefix for the string, we can ensure that all the backslashes are escaped. So, for example, if we have my path equal to R quotation mark C backslash news backslash today dot txt. Close that, and then we have print my path. Now this prints out exactly what we want. Now if we want to examine the variable directly without actually printing it, we will see that each backslash is escaped with another backslash. So let's just type in my path and execute this. So you can see that an extra backslash is added here. Now one thing to note is that backslashes always escape single and double quotation marks, even if it's a raw string. So we cannot end a raw string with a single backslash. So for example, something like this is not a good idea. Something like this is a good idea. Now, one thing that you need to note is that backslashes always escape the single and double quotation marks even in a raw string. That's why we cannot end a raw string with a single backslash. So for example, if we tried something like this with a single backslash, that would not be a good idea. Now, if we tried something with a double backslash, this would work. Raw strings are usually used whenever we work with regular expressions. Alright, now let's come to triple quotes. Triple quotes are mainly used to create multi-line strings. We generally use double quotes, 3 double quotes. We generally use 3 double quotes double quotes whenever we want to create a triple quote program. We generally use 3 double quotes to achieve this. So let's have a look at the following example. Let's say we want to print something like this. So we will put triple quotes here. This just automatically happens sometimes, so you just need to make it triple quotes. Let's add a bunch of underscores. Now in the next line, we will say lumberjack song. Which goes like this. I'm a lumberjack and I am okay. I sleep all night and I work all day. And then we have a few more underscores followed by closing quotation marks, and that's it. Now when we run this code cell, we get something like this. One thing to note here is that quotation marks can be included within these triple quoted strings without the need of being escaped with a backslash. Now, it's possible in some cases when we are using triple quotes, we may want to break our code up into separate lines with a new line, but we do not want that new line to show up in the final output. So we can escape this new line with the help of a backslash. Let's see how this would work. So let's say we have another poem that we want to print. So we will create our backslashes like this, our triple quotes like this, and we will start with the poem. So where Knights of the Round Table backslash we dance whene'er we're able, we do routines and chorus scenes backslash with footwork impeccable, we dine well here in Camelot backslash we eat ham and jam and Spamalot. And now we can close this with our triple quotes. And when we print this, we get an output like this. So if you notice, the backslashes at the end of lines 1, 3, and 5 prevent the line breaks in the output. Now let's talk about string indexing. Now, sometimes we have a whole sequence of elements, and we may need to find one specific element from that entire sequence. So for this, we use string indexing. Indexing is nothing but the process of finding one specific element from within a whole sequence of various elements with the help of the element's position. If you remember, strings are basically just sequences of characters. So we can use indexing to find one specific character within that string. Now, if we consider a string from left to right, the very first character of that string, which would be the character at the very left of the string, is at the position 0. But if we consider the string from right to left, the very first character would be at position -1. If you can see in this diagram here, this is illustrated with the help of the phrase Monty Python. So here, M is at position 0 and N is at position 11 when the string is considered from left to right. And when the string is considered from right to left, N is at position -1 and M is at position -12. Now let's see how we can find characters with the help of their positions using indexing. So let's consider the phrase Monty Python. Now the first letter will be phrase square bracket 0. So that will be the 0th position for the value that is assigned to the variable phrase, which is basically the 0th position of the string Monty Python. Now we print first letter. Next we have last letter, phrase -1, and then we print last letter. Then we have fifth letter, equal to phrase 4, and we print fifth letter. Next we have third letter, but from the end, equal to phrase -3. And then we print third letter from the end. Now when we run this, we get exactly the letters that we needed. So let's go through this very quickly. So we have the first letter, which will be at the 0th position. So just for you to know, when Python considers the positions of various characters within a sequence, it starts with 0 and it does not start with 1. So the first letter will be at the 0th position, the second letter will be at the first position, and so on. So here for the first letter, we take the 0th position and we print it out and it gives us M. Then we take the last letter, which is at -1 position, we print that out and we get N. Then we take the 5th letter, which would be at the 4th position, we print that out, 1, 2, 3, 4, 5 here, and we get Y. Then we take the 3rd letter from the end and we print the -3th position, and that is H. So this is how we can use string indexing. Now let's try an exercise which requires us to perform string indexing. Alright, so the objective of this exercise is to get a specific character from a phrase that is entered by the user. So basically, we need to write a program that does the following. First, it prompts the user to enter a phrase. Second, it tells the user what phrase that they have entered. Third, it prompts the user for a number. And fourth, it tells the user what character is at that position in the user's phrase. So this is just a sample output here. Now there's an extra challenge which we will see in a little while. First, let's come to the initial solution. So we will define our function as the main function. We have phrase, input, choose a phrase. Then we have print, your phrase is, and we will add this here. All right, then comma, phrase, then we add our separator here after this, which would be equal to this. So basically, we add an extra single quotation mark here to show the start and the end of the phrase that is given by the user. Then we have pause or position, which we need to convert into an integer. Then we input from the user which character. And in square brackets, we enter the number. Then we print character number, comma, position, comma, is, comma, phrase, pause. And that's about it. Now, when we run our main function, we are prompted to choose a phrase. So let's say we choose hello there. Sorry, hello there. Now it tells us that the phrase is hello there. Now it asks us which character. So let's say we want the character 3. So the character number 3 is L. As you can see here, it is L. Now let's just try this again because there was a slight little mistake here. This should work better. So let's choose our phrase. This time let's go with hello world. Oh, there was another mistake there. Anyway, let's go ahead with this. So which character? We will say character number 2, and this gives us L as well. Now, when we run this, we go with hello world. Now it asks us which character, we say 4, and it tells us that the fourth character is O, which is 0, 1, 2, 3, 4. Now let's have a look at the challenge. So as a Python programmer, we understand that the O in hello is at position 4 because Python starts counting with 0. But other people will not understand this, and they will think that the character at position 4 is L, and they will think that the program is wrong. So we need to fix our program in such a way that it responds as such a user would expect. And there's an extra little part here to output the character in single quotes. So let's see how this would work. So basically the same thing, def main. Or you know what? Let's actually copy paste this and let's work with this. Okay, so we have everything the same. So we have def main, we have our phrase, we have print your phrase is. Now, this is where we will have to make a change. So everything remains the same pretty much. All that we need to do is add -1 there. And then in this line, character number becomes position +1. Is. Now, after phrase and position, we add this single quote here, and we add our separator, which is empty. Now when we run this, let's choose a phrase. So we say hello world. It asks us which character, and it tells us that the character number is, character number 4 is L. Now, okay, there is a little bit of mix-up over here, so let's just quickly fix this. So let's add spaces here, and that should be pretty much it. Let's see if this works better. So we have hello world, number 4, character number 4. All right, so now there's something else that we need to correct. Okay, so all that we need to do is this. Now this should work correctly. These are all very simple things, and it's all a part of debugging, which is something that we will cover in a later lesson. But it's always good to know how to correct your program, because sometimes there might be very minor details that need to be changed, but that could affect the entire outcome of the program. So anyway, coming back to our code, hello world, number 4, and there we go. So this is the output that we require. Now let's come to slicing strings. Now let's talk about slicing strings. Previously, we have seen how to get a single character from a string. Now it may be necessary at some point to have to get a whole sequence of characters from the string. This is called a substring. In Python, we do this by slicing the string. We slice a string using the following syntax. So we have substring equal to original string, and then we specify, sorry, we have to use square brackets here. We specify the first string, rather the first position, and the last position. Now when we run this, this should help us to slice the string. So this would return a slice that starts with the character which is at this position, the first position, and it will include all the characters until this very last, the character at the last position, but it would not include the character at the last position. Now, if the first position is left out, it is assumed to be 0, and so it would start from the beginning. If the last position is left out, then it would be assumed that it is the entire length of the string, starting from whatever is specified at the first position. So let's have a look at some examples of slicing strings. Let's consider our previous phrase, Monty Python. Now let's say we want the first 5 letters. So we say phrase 0 to 5. And then we print first 5 letters. Now let's say we want letters 2 to 4. So we would say phrase 1 to 4. And we can print this. Letters 2 to 4. Sorry, I went to the next cell by mistake. Alright. Now let's say we want the letters 5 until the end. So that would be phrase 4, and we leave this blank. Then we print letters 5 to end. Now let's say, okay, let's actually try this. Let's say we want the last 3 letters. So that would be phrase -3, and we leave that blank again. Then we print this, last 3 letters. Now let's say we want the first 3 letters. That would be equal to phrase. We leave the first part blank and we specify 3 at the end. And then we print this. Now let's say we want 3 letters before the last one. So we will specify 3 letters before last. Phrase -4, -1. And then we print 3 letters before last. Now our last example can be copy of string phrase, and we just leave this blank here. And then we print copy of string. Now let's run this entire set of code. Alright, so you can see that this has thrown an error. That's because we have used 3 instead of the word 3. So let's make this 3, and we'll run this. Now as you can see, we've gotten the output that we wanted. Let's quickly run through this. So we wanted the first 5 letters, so we got the first 5 letters, 1, 2, 3, 4, 5, Monty. Next we wanted letters 2 to 4, so that would be O, N, T, and yeah, that's actually it, because we wanted only from the second position until the fourth position. Then we wanted letters 5 until the end. So that would be 1, 2, 3, 4. So starting from 5 here until the very end. That's what we got. Then we wanted the last 3 letters. So that takes N, O, and H. So we can see here, basically HON. Then we wanted the first 3 letters, which would be MON, and that's what we got here. Then we wanted 3 letters before the last letter. So that would be T, H, and O. And that's what we got here. Now, finally, we just wanted a copy of the entire string, and that's exactly what we got here. So this is how we can slice strings as required for our program. Now let's get into an exercise involving slicing strings. So in this exercise, we are going to do the following. We will prompt the user to enter a phrase. We'll tell the user what phrase they entered. We'll prompt the user for a start number. Then we'll prompt them for an end number. And then we'll tell the user the substring within single quotes, which starts with the start number that is provided by them and ends with the end number that is provided by them. Now this is a sample output over here. There is an extra challenge along with its output, but we will get into that a little later. So the solution would be something like this. We would define our main function, then we give the program our phrase. Rather, we define the variable phrase, and then we assign it to the input function, in which we ask the user to choose a phrase. Let me just capitalize this. Then we print your phrase is single quotation mark, comma, phrase, comma, and then separator. There we go. Now we define our position 1 variable, which needs to be converted into an integer, and we input this as character to start with and enter number. Then we have position 2, integer, input, character to end with, square brackets, enter number. Then we print your substring is, comma, phrase, position 1, position 2, comma, and there we go. Now before we continue, let's add +1 here. So this would include the 9th position, rather than excluding the 9th position. Now we can call our main function. So we choose a phrase, we'll go with hello world. We choose a character to start with, we will go with 4. Character to end with, go with 9. And there we go, we get the substring like this, which is what we have gotten in the sample output. Now let's have a look at what the challenge is. So the challenge is, as before, to make the program respond as users would expect. And this is the sample output for the challenge. So let's work on this. Now, as before, we can just copy the same piece of code and let's work with this. So the main changes that we need to make are remove +1 from here, make this -1, and that's it. Now let's see how this works when we run the code. Choose phrase, hello world, start number 4 and number 9, and we get this as our substring. And that's exactly what was obtained in the sample output as well. So in this way, we can slice strings to get a certain set of characters from an entire string. Now let's have a look at concatenation and repetition. Concatenation is nothing but putting strings together. For example, in Python, we can use concatenation to put two individual strings together as a single string. This is done with the help of the plus operator. Usually this is done to combine variables with literals. So let's take a look at this example. Let's say we have username, input, what is your name? Then we give a greeting, hello, plus username plus exclamation mark. Then we print greeting. Now when we run this, it prompts us for our name. So let's give the name Bob, and it says, hello Bob. So the interesting thing here is that we do not have to use any special function or anything like that. All we had to do was just use the plus operator, and we were able to combine the variables and the literals into one entire line. Now let's have a look at repetition. Repetition is basically the process of repeating a string for a certain number of times. In Python, repetition is done with the help of this operator, the multiplication operator. Let's have a look at the following example. Let's say we have a variable, one night says, and we have the word me. Then we have a variable, many nights say, and then we take the previous variable, one night says, times 20. Then we print many nights say. So there we go. We now have what one night says printed several times to show us what many nights would say. So this has come out 20 times. And this is basically how repetition works. Now let's get into an exercise to see how repetition works. So using repetition, we can improve the insert separator function so that the number of times a separating character shows up is passed into the function. If you remember, we had used this function in a previous example. Now what we need to do is, we need to create a program that includes the insert separator function so that the number of times the separating character shows up is passed in as a parameter. This should default to show up 30 times. Now we need to, after that, we need to modify the calls to insert the insert separator function. After that, we need to modify the calls to the insert separator function so that they pass in an argument to the new parameter. So this is basically the output that we are trying to achieve. So let's have a look at how this is done. So we define our function, say hello, with a parameter name. Then we print hello, comma name, comma exclamation mark, comma separator. Then we have insert separator. And within this function, we pass the parameters s equal to sign, repeat 30. Print s times repeat. Next, we define our recite poem function. Then we print, how about a nursery rhyme? Then we insert separator underscore 20. And then we print Baba black sheep, have you any wool? Yes, sir. Yes, sir. 3 bags full. 1 for my master and 1 for my dame. And 1 for the little boy. Who lives down the lane. Next, we define the say goodbye function with name as a parameter, and we print goodbye name exclamation mark and separator. Then we define main, your name equal to input, what is your name? Insert separator, underscore 20, say hello, your name, insert separator, recite poem, insert separator, say goodbye, your name. Now let's run this and see what happens. So it asks us what is our name. We'll say Jill, and it prints out the following result. What is your name? Jill. Hello, Jill. How about a nursery rhyme? Then it prints out the nursery rhyme and says, goodbye, Jill. And this is how we can use repetition within our program. Let's have a look at how we can combine concatenation and repetition. Now, when we do this, we need to remember that repetition would take precedence, which means that it would occur first. Let's consider this example. Let's say we have A plus B plus 3. No, you know what? Let's make this times 3. And then we will say plus C. Now when we run this, we get A, triple B, and C. That means that the repetition occurred first, which was B 3 times, and after that it was concatenated with A and C. Now, if we want to force the concatenation to take precedence, we can do this with the help of parentheses. Let's consider the same example. This time we will use parentheses, and within that we will put A plus B times 3 plus C. Now when we run this, we get AB, 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 C. That means that A is concatenated with B, then AB is repeated 3 times, and finally AB, AB, AB is concatenated with C. Now let's have a look at another example of combining concatenation with repetition. Let's say we have a variable called flower, for which the value will be a user input. So we will input favorite flower. So we'll ask the user, what is your favorite flower? Then we have a variable reply equal to a flower, and then within brackets is a plus flower times 2 plus period. Now when we print reply, we get what is your favorite flower. So let's say we put tulip. So we get a tulip is a tulip is a tulip. And so as you can see, this is a small little typo here. We need to put a space over there. So now if we rerun this and we say tulip again, a tulip is a tulip is a tulip. So this is how we can combine concatenation with repetition. Now, what we need to remember is that Python strings are immutable. This means that they cannot be changed. But it is easy to make a copy of a string and then assign the copy to the same variable as the original string. So let's consider this example. Let's say we have a variable called name in which we input a name. So let's say Jill. Then we will say print ID of name to find out the ID of the object. Then we have name plus equal to, and let's just put a y there. Then we will print name. Then we will print the ID of the name. And yeah, that's it. Now when we run this code, so first we get the ID of Joe. That is this. Now we concatenate this with name and it becomes Joey. And then when we print that and we print the ID of name changes. So basically when we modified the string in the variable, the ID of it has changed. Now because strings are immutable, or which means that they are unchangeable, the various methods that operate on the strings cannot modify the string in its place, so they return a value instead. Sometimes the value is a modified version of the string, but what we need to understand is that the original string remains unchanged. So for example, let's consider the upper method, which returns a string in all capital letters. So let's say we have name equal to Joe. Then we print name.upper. Yeah, that's actually about it. So we get Joe, but capitalized. Now if we want to change what the original variable is, we need to assign the returned value back to the variable. So for example, we have name equal to Joe. We have name equal to name.upper. And then we have name. This gives us Joe. So as you can see here, we have taken the variable name and we have reassigned it to the capitalized version of this value, which is Joe. Now let's move on to some common string methods. We'll start with string methods that return a copy of the string. So for example, we have string.capitalize, which would return a string with only the first letter that's capitalized. Then we have string.lower, which returns a string with all lowercase letters. We have string.upper, which returns a string with all uppercase letters. We have string.title, which returns a string with each word beginning with a capital letter followed by all lowercase letters. And then we have string swap case, which would return a string with the case of each letter swapped. Let's illustrate these different methods. First we have, let's say we have a string hello, but with different with different cases of characters. Now when we say capitalize, this prints out hello with the first letter in capital. Now let's say we have the same thing, E-L-L-O dot lower. This would give everything in lowercase. Now once again, let's take the same string and let's do upper, which would give everything in uppercase. Now let's say we had a string hello world dot title. This would give the same string but with the first letter of each word capitalized. Now let's once again use hello dot swap case. This returns the string hello, but the case is swapped. So for example, lowercase h becomes uppercase h, uppercase E becomes lowercase e, and so on with L, L, and O. Next we have string.replace with parameters old, new, and optionally count. So this will replace some letters from a specified string with so this would replace specified letters from a given string with new letters, and we can change the number of letters that we want replaced. So let's have a look at an example. Let's say we have the string mommy. We say dot replace, we put M, comma, B. So it becomes Bobby. Now let's say we have mommy once again. We say M dot replace. This time we say M, comma, B, comma, and we give the count as 2. So this becomes Bob my, because we have specified that we want only 2 of the M's to be replaced. So it replaces the first 2 M's and it leaves the third M as it is. Now let's have a look at some methods that strip characters. So let's say we have some set of characters. Now we have string.strip characters, which returns a string with leading and trailing characters removed. Then we have string.lstrip characters, which returns a string with only the leading characters removed. Then we have string.rstrip, which returns a string with the trailing characters removed. The characters default to white space. Let's have a look at an example. Let's say we have hello dot strip. So this would give us hello. So what happened here is that the white space was stripped from this entire string, and that's why we were left with just the word. Since we have not specified anything in here, it defaulted to white space. Now let's say we had hello, oh, this should be in quotation marks. So hello dot strip, but in this case we will say lstrip, and we specify h. Sorry, we have to put quotation marks here. Now this gives us hello. Now let's say we have hello dot rstrip and we specify O. This would just give us hell. Now let's say we have string methods that return a boolean. Now let's have a look at string methods that return a boolean. So we have string.is lnum, which returns true if all characters are letters or numbers. Then we have string.is alpha, which would return. First we have string.is alnum, which returns true if all characters are letters or numbers. Then we have string.is alpha, which returns true if all characters are letters. Then we have string.is lower, which returns true if the string is all lowercase. We have string.is upper, which returns true if the string is all uppercase. And then we have string.is title, which returns true if the string is title case. So let's have a look at some demonstrations of this. Let's say we have a string hello world, and we say dot is al num. Now this would say false. This is because all the characters are not letters or numbers. We have an exclamation mark here as well as a white space. Now let's say we have the same string hello world, dot is alpha, once again it's false because we still have an exclamation mark and the white space. Now let's say we have hello dot is lower. This would be true because all the letters are lowercase. And let's say we had the same thing but with capital letters and we say dot is upper. This would return false, true, because everything is in uppercase. Finally, if we have hello world dot is title, this would return true because the first letter of the first word and the first letter of the second word are both uppercase. Now let's have a look at string.isSpace. This would give true if the string is made up only of white spaces. Let's have a look at an example. So let's say we had something like this. And when we say dot is space, we get true. Now let's say we had something like this. And we say dot is space, we get false. Now let's look at string.isDigit, string.isDecimal, and string.isNumeric. As is quite obvious from the names itself, these all check to see if the string has only numeric characters. Now all three of these will return true if the string contains only Arabic digits. Let's have a look at an example. Let's say we have a number like 42 and we say isDigit. This gives true. Now let's say we had this was isDecimal. This also gives us true. Now let's say we did isNumeric. This would also give us true. Now all three will return false if any character is non-numeric. So let's say we have 4.2. So when we say isDigit, it says false because of the decimal point in between. Now let's say we did the same thing but we did isDecimal. This gives us false as well. And finally, we say isNumeric. This will also give us false. Apart from this, the difference is mainly just academic for most programmers. So if you're wondering what to use, just remember that it doesn't really make much of a difference, but isDigit is the most popular one, probably because the name most closely matches what the function is meant to do. So if you want, you can use isDigit. Next we have string starts with and string ends with. As the name suggests, string starts with the arguments of prefix, start, and string ends with the arguments of prefix, start, and end. Both return true if the string starts with a prefix or if the string ends with a suffix, respectively. So let's say we have hello dot starts with which gives us true. And then we have hello dot ends with, which gives us true. Now let's have a look at some string methods that return a number. So we have string methods that return a position of a substring. So we have string.find, which would return the lowest index where the substring is found. It would return -1 if the substring isn't found. Then we have string.rfind, which would return the highest index where the substring is found. It would return -1 if the substring is not found. Then we have string.index, which is the same as find, but errors when the substring is not found. Then we have string.rindex, which is the same as rfind, but errors when the substring is not found. Now, all of these methods would start looking at the start index and end looking at the end index if the start and the end are specified. As you can see here, they are parameters that can be mentioned when we are calling these methods. So let's have a look at some examples of how we can use these methods. Let's say we have a string, hello world, and we say dot find L. This would return 2, which is the position of L in the string. Now let's say we have hello world again, and we say dot rfind. And once again we say L, so it would give us 9. That's because L is found over here, which is the 9th position in the string. Now let's say we once again have hello world, and this time we say index, and we give L, so it would give us 2. And then if we take the same string and we say dot rindex L, we get 9. Next we have string.count. This would return the number of times that the substring is found, and it starts looking at the start index and ends looking at the end index, same as before. So to demonstrate, we will take our string hello world, and we will say dot count L, and we get 3. That's because we have L, 1, 2, and 3 times within the string. Next, we have string formatting. Now, Python allows us to format strings because it has several options to do this. So the first would be the format method. This is one of the most common ways to format strings, and it is combined with the format specification mini language. We'll start with a simple example. Let's say we have curly brackets, 0 is an 1 movie. Then we would say dot format and then we would say we'll just put a random movie in here. Let's just call it Spider-Man. Just randomly throw in Spider-Man there. And then we would say awesome. Now when we execute this, we get Spider-Man is an awesome movie. So here, the curly brackets are used to indicate a replacement field. That means whatever is over here needs to be replaced by whatever is over here within the brackets after format. The curly braces can take position arguments that are specified either by the index, as we have mentioned over here with 0 and 1, or by name, as we will see in the next example. So let's say we have curly brackets, movie is an adjective movie. And then we say dot format movie equal to Spider-Man and adjective equal to awesome. And when we execute this, we get the same thing as before. Now, we can also omit the field names or the position arguments. We'll see this in the next example. So let's say we have curly brackets is an curly brackets movie. We say dot format Spider-Man, comma, awesome. When we execute this, we get the same result as before. So when we omit field names, what happens is the first replacement field would be at the 0th index, and the second replacement field would be at the first index, and so on, depending on our code. Now let's take a look at a few more examples. Let's say we have Spider-Man plus is an plus awesome plus movie. Executing this prints the outcome that we want, or we can do it this way. Movie is Spider-Man, adjective is awesome, movie plus is an plus adjective plus movie. Right. Let's put a space before movie. Now this would give us a better output. Now this is what we want. Of course, we can add an exclamation mark here like we've done before, but that's kind of irrelevant here. Now, when we are doing multiple kinds of concatenation, it's just easier and more efficient to use the format method. But the format method is used for more than just concatenation. It can also be used to format replacement strings. It is mostly used to format numbers. Now we have format specification. Format specification is separated from the field name or the position by a colon, something like this. So we would have field name, colon, format specification. Now, since the field name is usually left out, we commonly write this like this, colon, format specification. The format specification is, we have fill, align, sign, width, comma, dot precision, and type. Now, this can look a bit complicated, so we will just break this down. So let's look at type first. Type is specified by one letter specifier, like this. So we have curly braces, colon S, is an, curly braces, colon S, movie. And we say dot format Spider-Man, comma, awesome. Now when we run this, we get Spider-Man is an awesome movie. Over here, the S indicates that the replacement field needs to be formatted as a string rather than as any other data type. Now, there are many other different types as well, but the most common types that we would be working with would be strings, integers, and floats. By default, the formatting for strings and integers are S and D respectively. So basically the S is for string and the D is for decimal integer, which is generally what we would want. Now let's consider the following piece of code. Let's say we have sentence equal to, on a scale of 0 colon D to 1 colon D, I give two colon S a 3 colon D. Now we will say sentence equal to sentence dot format 1 comma 5 comma Spider-Man comma 6, and then we will print the sentence. Now let's so this would be the full formatting strings. Now let's try to simplify this by removing the field names or the indexes. So this becomes sentence equal to, on a scale of colon D to colon D, I'd give colon S a colon D. And then we say sentence equal to sentence dot format 1 5 Spider-Man 6. Then we would print the sentence. Now let's say we want to simplify this further by removing the default type of specifiers. So we would say sentence, once again on a scale of, this time we just put colon to colon, I give colon a colon. Then we have sentence equal to sentence dot format 1 5 Spider-Man 6, and then we say print sentence. Now we can also remove the colon separator since the field name and the specifier are gone. So we say sentence equal to, on a scale of curly braces to curly braces, I give curly braces a curly braces. Then we have sentence dot format 1 5 Spider-Man 6, and then we print sentence. Now let's run this entire code cell and see what we get. So having done all of this, we get the same results. The advantage of this final line of code is that it is very simple. It doesn't have too much to type. But the disadvantage is that it is not very clear. For somebody who is seeing this code for the first time and who has not written this code, it would be very unclear for them. So we can make it clearer using field names. Something like this. On a scale of low to high, movie is a rating. And then we say dot format low equal to 1, high equal to 5, movie equal to Spider-Man, and rating equal to 6. And when we run this, we get the sentence that we want. So this is basically how we can work with strings and using format specification to create these kind of strings. So this is basically how we can use format specification to work with various kinds of data types. Now let's have a look at floats. Usually when we format floats, we use f as the one-letter specifier. It has a default precision of 6, and if we don't specify either the type or the precision, then floats will just be as precise as they need to be. Let's have a look at some examples. Now, when we have the fixed point type specified, it would be something like this. So we import math first, then we say pi equals curly braces colon f dot format mat.pi. When we run this, we get pi equals 3.141593, up to 6 decimal places. Now when we don't have any type specified, if we say pi equals curly braces dot format mat.pi, we get a much larger value of pi. Now another option to format floats is percentage. We'll cover that very soon. Now let's have a look at precision. Precision is specified before the type and it is preceded by a decimal point. So let's have a look at an example. Let's say we have the same sentence, so pi equals curly braces colon dot 2f dot format mat.pi. this gives us pi equals 3.14. Now here we have specified that we want it precise up to 2 decimal points, which is why we just got 3.14. Now if we had made this 3f, we would get up to 3 decimal points, and so on depending on the number that we add here. Now let's have a look at separating the thousands. When we insert a comma before the precision value, we can separate the thousands. For example, if we have curly braces, colon, comma, dot 2f, dot format, and then let's say we have 1, 0, 0, 0, 0, 0, 0. Now when we run this, the comma is used to separate the thousands. Next, let's have a look at width. So the width is an integer that indicates the minimum number of characters of the resulting string. That's pretty explanatory on its own, right? So if the passed-in string has fewer characters than the specified width, padding will be added. By default, padding is added after strings and before numbers. This is so that strings are aligned to the left and numbers are aligned to the right. So let's just have a look at some examples so that this makes a lot more sense to you. So let's say we have colon 5 within curly braces, and we say dot format ABC. So as you can see here, padding has been added. Because ABC has only 3 characters, but the number specified here is 5. So padding has been added to make sure that it corresponds to the minimum number of characters for the string. Now let's try curly braces colon 5 dot format, and let's go with 1, 2, 3. This once again gives us padding because we have only 3 characters, but we've specified 5, and as mentioned, the padding comes to the left for numbers, while for the letters the padding is to the right. Now let's take another example. Let's say we have curly braces colon 5 dot 2f dot format 1, 2, 3. Now when we run this, we get 1, 2, 3.00 because we have specified that we want 2 decimal places, and we have given the number of characters to be 5, or the width to be 5. Now let's have a look at sign. Now by default, negative numbers are preceded by a negative sign, but we have positive numbers that are not preceded by a positive sign. Now if we want the sign to show up in the program, we need to add a plus sign before the precision. Let's have a look at an example here. So let's say we have pi equals curly braces colon plus dot 2f dot format mat.pi. Now here we have pi equals plus 3.14. If we had not specified the plus here, it would have just appeared as 3.14 without the sign in front of it. So when we specify the plus, we get the plus shown over here. Now let's look at alignment. So we can change the default alignment by preceding the width with any one of these options, either left aligned, which is the default for strings, right aligned, which is the default for numbers, or this sign, which would be padding added between signs and digits, and this is only valid for numbers, or centered. Let's take a look at some examples here. So let's say we have curly braces, colon, then we have the right angle bracket, 5, dot format, ABC. This gives us ABC with padding to the left. Now let's say we have the same thing. Let's copy and paste the same thing here. But instead, we will change this, and our format becomes the value within format becomes 1, 2, 3, and we remove the quotation marks. Now when we run this, we get 1, 2, 3, and there's padding to the right. Now once again, let's copy this, paste it here, and let's do this. Now when we run this, we get 1, 2, 3 aligned to the middle. And finally, if we have colon equal to plus 5 dot format 1, 2, 3, this gives us plus space 1, 2, 3. Next, we have fill. So by default, spaces are used for padding, but we can change the Now, by default, spaces are used for padding, but we can change this by inserting a fill character before the alignment option. Let's have a look at an example. So let's say we have curly braces, colon, dot, centered 10.2f, dot format, mat.py. And when we run this, as you can see, the white spaces have been replaced with dots. Now we can do the same thing but with a dash. So let's copy this, paste it here, and we will replace this with a hyphen. Now when we run this, instead of getting dots, we get hyphens. Next we have percentage type. So we mentioned earlier that another option for type is percentage. Let's look at that a little more. So let's say we have a variable called questions, to which we assign the value 25. We have another variable called correct, to which we assign the value 18. Now we have a third variable, grade, which is equal to the result of correct divided by questions. Finally, we print grade. We get 0.72. Now, let's say we have colon dot 2f dot format grade. This gives us 0.72. Now, let's say we had the same thing, but this time instead of 2f, we say 2 and we put the percentage symbol there, while everything else remains the same. This gives us 72%. Now, if once again we have the same thing, except in this case we have colon dot 0%, this gives us 72%. So if you can see here, when we just do this calculation first, we just get 0.72. Now, when we format in such a way that we just have .2f, it gives us 0.72. But if we put 0.2%, we get 72.00%. And then if we specify 0.0%, we just get 72% without the decimal places. Now let's have a look at long lines of code. Now in Python, there is a style guide that gives us various kinds of recommendations of how to make clean and good code. So the Python style guide recommends that each line of code should be limited to 79 characters. However, this can be a little difficult since each line of code is considered a brand new statement. However, this can usually be accomplished by following three different combinations. So the first would be breaking method arguments across multiple lines. The second is concatenation, and the third is triple quoted multi-line strings. Let's have a look at the following code. So let's call this example 1. Let's say we have a phrase that says, on a scale of flower bracket to flower bracket, comma, I'd give flower bracket, flower brackets. Put a full stop there. And then we have dot format one 5 Spider-Man 6. Now we print the phrase. Then we have location equal to pawns. Then we have items equal to swords. Now I know this sounds very random at the moment, but as we go along through the rest of the code, you'll understand what I'm talking about. Then we have beings as masses. Then we have adjective as farcical. All right, now we will call this example 2, and this had, just a minute, let me separate this out a little more. All right, now this would have quote, listen, listen, I did a quick search of the flower brackets plus, and I found quotation marks, and I found some coins and flower brackets and swans. Plus the flower brackets aren't pleased. They call it incompetent plus the flower bracket situation is cause of the government. All right, so we have some kind of a little poem thing here, and we have dot format. Then we have location, items, beings, and adjective. And before I forget, these need to be within quotation marks to signify that they are strings. There we go. Now we print quote. Next we have the third example, which would be the same thing but using triple quotes. So let's call quote our variable. Now over here we will have triple quotes. And we say the same thing pretty much. So let's just copy paste this for now. We will paste it here, remove all the unnecessary quotation marks. All right, and after doing this, we will close this. Then we will say dot format, location, items, beings, and adjectives. Adjective. Then we will print quote. Alright, so now we have just typed a lot of things. Now let's run this code and let's hope that it works. There we go. So we see that the code does work, but there is something that needs to be changed over here. Now over here what we need to do is, instead of putting the plus sign, we put a backslash. So here, 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 and that should be about it. Now what we need to do here is and we delete this. Then we can delete this. Oh, yeah, these are just, regular coding issues. There we go. Now it is fine. So basically what happened here is the backslashes helped each line to escape the new line character. So that's how we can work with long lines of code. Now we will jump into formatted string literals, or f-strings. Now, formatted string literals, or f-strings, they work in such a way that their syntax embeds the format function within the string itself. So we will see this in a demonstration. This demonstration will compare string concatenation and string formatting with the f-string syntax. So let's first import the math module, and then we have username equal to input, and we ask the user, what is your name? Now the first thing that we have is concatenation, which would be greeting equal to hello plus username plus exclamation mark. Then we have the format method, which would be greeting equal to hello curly braces exclamation mark dot format username. Then we have f-string greeting f hello curly braces username exclamation mark. And we print greeting. Finally, we have format specification, where we have pi statement equal to f pi is mat.pi colon dot for f. Let's make it precise up to 4 decimal points. Then we close this and we print pi statement. Then when we run this, it'll ask us our name. So let's go with Mary. It says hello Mary, and then it says pi is 3.1416. So what you need to note here is that the curly braces that are within the f string contain the variable name, and optionally they can contain a format specification, as this has over here. Also, this is prepended with an f. Everything else is pretty much the same as we have learned earlier, since it's the same formatting function that is being called. So let's take a look at a couple of more examples. So let's say we have a movie, Spider-Man. Let's say we have an adjective, awesome. And then we have F movie, sorry, this should be within flower braces, curly braces rather, is an adjective movie. And when we run this, we get an error. So let's see what's the issue here. Okay, the issue is that I forgot the apostrophe here. There we go. Now, let's try something like this. So we'll say low 1, we'll say high equal to 5. We have rating equal to 6. Then F, and on a scale of low to high, movie is a rating. And we print this. There we go. Now let's say we have F pi equals curly braces mat.pi colon F. We print this, and now we can try pretty much the same thing. Actually, let's copy paste this, remove that, and over here instead we will make it pi colon dot 2f. Then we have f 1 0 0 0 0 0 0 colon 2f. So let's separate out the thousands. There we go. Then we have f ABC. Let's put that there, and we'll put this here. Colon 20. And we close this. Then we have F 1 2 3 colon 20. And we shouldn't forget the quotation marks. Then we have F 1 2 3 dot 5 dot 2f. And once again, we have a little syntax error here because this should be colon, and so on. Now we can continue, but let's move on to the rest of the lesson. And in your free time, you can always practice more exercises that involve all of this. Let's take a look at built-in string functions. Now, the first one that we'll be covering is string object, which converts an object to a string. Now this is very simple. All we need to do is just type in str and then whatever our object is. So let's say we have foo. Now foo is already a string, so it'll remain a string. Now let's say we have the number 999. When we run this, it becomes a string, and we know this because there are quotation marks like this at the sides. Now let's say we have string mat.pi. So pi now becomes a string. Next we have length of string. This would give the number of characters within the string. So if we say length of foo, this gives us 3 because foo consists of 3 different characters, or rather 3 characters. This gives us 3 because foo consists of 3 characters. Next we have min and max. So the minimum argument function returns the smallest value of the passed-in arguments, while max will return the largest value of the passed-in arguments. So let's say we have min w B. This would give us B. Now let's say we have min A capital B and C. This gives us capital B. Then when we try max of W, E, B, this gives us W. And when we try max of A, capital B, and C, we get C. Now from here we can understand that all uppercase letters come before the lowercase letters, which is why when we find the minimum of A, capital B, and C, we get capital B as the minimum rather than getting A as a minimum. The minimum and maximum functions can also take an iterable that contains values to be compared. This will be covered in a later lesson. Now let's go to the fifth exercise, which is outputting tab delimited text. In this exercise, what we need to do is write a program that prompts the user repeatedly for company name, revenue, and expenses. It must then output all the information as tab delimited text. And so in this exercise, we can use either the format method or fstrings, or even a combination of both. So the first step is to copy and paste the given code into our editor, and the second step is to modify the add header function so that it creates a new header row and appends it to output. The 4 headers should each take up 10 spaces to be aligned to the center and be separated by tabs. Now we need to modify the add rows function so that it adds a row to output by prompting the user for values for company, revenue, and expenses, and then calculating the profit. So all columns should be 10 spaces wide, the company name should be left aligned, and the other 3 columns should be formatted in US dollars and right aligned. Then we can save, run this file, and try entering it in our code for at least 3 companies. So this is the given code, this is our sample output, and this is where we write our solution. So let's take this given code first. Copy it here. Now we will start with output. Let's call this underscore output. And then we have definition add headers. This is where we write our own code. So we will say global and then underscore output. And then we can remove pass actually. So then we have C header, floor bracket, colon, center 10 dot format company. So we can do pretty much the same thing in the next line, but in this case it would be our header and this would be revenue. Now once again paste this. We will change this to expenses, and this would be E header. Finally we have P header equal to this and change this to profits. Then we have underscore output plus equal to flower brackets \t flower brackets \t flower brackets \t flower brackets n dot format c underscore header r underscore header e underscore header and p underscore header. Alright, so this is for the first function, which is add headers. Now we have the second function, which is add row. In this, what we need to do is first define our global variable output with an underscore. Then we have C equal to input company. Then we have R equal to float. And then input revenue. Then we have E equal to float input expenses. Then we have P equal to R minus E. Then we have C string equal to flower bracket colon all of this dot format C. Then we have R string equal to colon greater than 10 comma 0.2f. And then we have dot format R. Then we can kind of copy the same syntax. Dot format R. Then we have P string dot 2f dot format P. Then we say new row equal to flower bracket \t, flower bracket \t, flower bracket \t, flower bracket \n. Dot format C string, R string, E string, and P string. All right, so this is done. Then we have, we need to output plus equal to new row. And the rest is from the code that was given before. Yeah, this should give us what we need. Let's just give some random company names. So let's go with IBM. Revenue, we'll just keep this as unrealistic as possible. So we'll say 10,000. And we'll say expenses are 5,000. And do we want to go again? Yes. So we'll give our second company, Google. Revenue can be 20,000. And expenses can be 7,000. Go again, yes. This time we will give Amazon. Revenue can be 25,000. And expenses can be 10,000. Now we don't want to go again, so we press Q. And there we go. So this is the result that we get from running this program. So that's about it. So in this lesson, we have learned how to manipulate strings, and we have also learned how to format strings.